Okay, so now we're going to look at some examples where we use the constant growth model. Example 1, 0 growth rate. What would the expected price to be today to be if G is 0 and if we know that the dividends are $2 for each year? Okay, so in this case, we have a constant growth rate, G, as 0, which means we have our dividends do not grow. Okay, they're constant for each period. It becomes perpetuity. So using dividend discount model or constant growth model, we want to discount all these future $2 dividends to present. Okay, and these $2 go on forever. So this is the same as looking for the present value of perpetuity. Okay, and we can also use our formula of the constant growth model. P0 equals D1 over RS minus G. Okay, D1 here is the payment, $2. RS minus G becomes only R because G is 0. Okay, so this constant growth model becomes the formula for present value of perpetuity. Okay, they're the same thing here because G is 0 and dividend becomes the same as the future payments. So we just use this $2 divided by 13% as the given stock return. Okay, so we have 15.38 as the stock price. Okay, when G is 0, P0 becomes D1 over RS. Looking for the stock price for this constant dividend stock, it's the same as looking for present value of a perpetuity. Okay, and this RI or RS here, we can call it stock return. It is also the cost of equity for us. Okay, the first example is relatively simple. The second example here is of negative growth rate. Okay, what if stock A pays a dividend of $2 per share today, which means D0 is 2. Okay, if the dividend is paid today, it is D0 and it's $2. And we have G as negative 6%. Cost of common equity is 13%, which means RS is 13%. We want to know the expected price today, which is P0 equals D1 over RS minus G, which is D1 is also D0 multiplied by 1 plus G over RS, 1 plus G. So we can just plug in the numbers using D0, $2, multiplied by 1 plus G, okay, but because G here is negative, so we use 1 minus 6%, we have 94%, which is 0.94, and we divide by RS, which is 13%, minus G, so we minus negative 6%. Okay, so we have 1.88 divided by 0.19 as 9.89 for our stock price. Even though the dividends are declining because we have a negative G, the stock is still producing cash flows and therefore has positive value. Okay, so even though the dividends we get are decreasing, but we're getting dividends still all the time, so the stock price should be positive. Okay, and in this case, the capital gains yield, again, according to our conclusions, capital gains yield under the constant growth model setting should be G. Okay, that should be the same as the growth rate of price, the growth rate of dividend. It is G, it is capital gains yield. Here is negative 6%. For dividend yield, it is the total stock return R minus capital gains yield, okay, which is 13% minus negative 6%, which is 19%. Since the stock is experiencing constant growth, dividend yield and capital gains yield are constant. Dividend yield is sufficiently large, 19%, to offset the negative capital gains yield. Okay, so we have a negative capital gains yield, but because our large dividend yield, our total return is still positive. Example 3 here. What if we want to know RS, total return. And we know D1 as 1.25, G as 5.5%, P0 as $44. What is stock's expected total return, RS, for the coming year? Okay, from the original model, P0 equals D1 over RS minus G. We can put RS on the left-hand side, so RS minus G becomes D1 over P0, and RS becomes D1 over P0 plus G. Okay, then you can plug in D1, P0, G, the three numbers given here. So we have RS as 8.34%. And again, this R is the same as the RI in the CAPM model. Okay, another example. What if we know D0 as 2.25, G as 3.5%, P0 as 50? What is dividend yield? We know this is a constant growth model setting, so dividend yield, D1 over P0, it is actually RS minus G. It is also D0 multiplied by 1 plus G over P0. Okay, so we just plug in the numbers D0, G, and P0 to here. We can get dy as 4.66%. Okay, we can solve for dy by using its definition here. You can also solve for RS first and then minus G to get dy, but it's easier if we use definition here. Okay, one more example of positive growth rate, positive G. The company just paid their dividend $2. Just paid, okay? So D0 should be $2. And the growth rate should be 6%. G is 6%. Risk-free rate in the market is 7%. RRF 7%. Rate of return for the market portfolio 12%. RM 12%. Company has a beta of 1.2. Beta I 1.2. Find the expected dividend stream for the next 3 years and PVs. Okay, we know D0s, and we can just multiply by 1 plus G to the power of T for the next 3 years. Intrinsic value of the stock. We can, of course, use constant growth model because we have a constant G. Expected market price of the stock 1 year from now. We want to know P1. Okay, question B here is asking for P0. We also want P1. We also want current yield, capital gains yield, and total return. Okay, so here you can probably try to solve for this question by yourself. Okay, try to draw the timeline, draw D0, and try to calculate D1, D2, D3, and their present values, add them up to get P0. Or you can solve for P0 by using D1 over RS minus G. We don't know RS here, so you probably need to use CAPM to calculate RS. And you could use P1, you could use P0 multiplied by 1 plus G to get P1. And you can use current yield, capital gains yield, and total return formulas to get these three concepts. Okay, the solution is on the next page. I'm going to discuss on the next video, but if you can challenge yourself to pause the video for now and work on this question on your own. And you can refer to all the formulas on the notes in the first 6 pages. Okay, so I'll discuss the solutions in the next video.